Hello, good day. My name is Topman Paul-Dike, and this is the first section of the Simple Shell series. Yeah, so I've outlined the objective, the things or the subtopics that we are going to cover. And then after which we'll be able to write our own simple shells, even the newbie. Yeah, so long as you know something about C and you can write some C programs. And you are really willing to read, you know, and you are teachable. You are available to learn. You will learn these things. Okay, I hope to cover all these things. Actually, I hope to. I want to sincerely apologize. This was supposed to take place the other time in the live section, but we got the network interrupted it, and I couldn't help it. But here we are. So I want you to pay close attention to this. Don't be in haste. Don't be under pressure. Just pay, just calm down and learn. Okay, calm down and learn. So if you're live with me right now, you can feel free to ask questions if you have anyone, anything you don't understand. Feel free to ask. If you're watching from YouTube, you can post your question as a comment, and I will surely respond to it. By the way, if you're not subscribed to the channel, please, it's simple. Just have a lot of materials here that could help you. Okay, just click subscribe, and you're good to go. Make sure you click on the notification bell. Make sure it's there so you can get notifications when new videos are posted. I believe so much in peer learning, and I love to share the little knowledge I have with my peers. All right, that's by the way. Now let's. One more thing, please don't just admire my work and say in your mind how helpful it is. Sometimes post some good comments about how helpful it was. You can correct me on something you think I should improve on. And when you like the video, don't just like it in your mind, like it in real life. Enough of the talking. Let's get straight into business. Introduction. What is a simple shell? What is a shell in this first place? Before we talk about simple shell, because for you to be able to implement your own simple shell, you should be able to tell what a shell is. I hope this thing is as visible as I think it is. I just hope so. I think I'm going to dim this transparency a bit so that um okay, this is okay. All right, great. So when I do ls, something happens, right? Okay, we're coming to that. These are the things I want to cover into this section. Hopefully I'm going to cover them all, but I'll begin by talking about. Okay, I'll begin with the first one. What is a terminal? What is a shell, and what is a shell prompt? Now, this thing I just brought out here is a terminal. You see that I can customize it. I was the one that gave you this color, so yours could be purely black. It's fine, but it's a terminal. That's what we call a terminal. Now, what is the shell prompt? The shell prompt is this thing that prints here, that prints out and waits for you to enter command, right? You may have noticed that um, uh, you may never have found two computers or two systems having exactly the same share prompt. Yeah, the share prompts may never be exactly alike, right? But one thing that's likely to always be there is this dollar sign. This dollar sign as a last thing, okay, or an ash or pound, whatever you call it. So ash means you're signing as a super user. Dollar means you're signing the um, as one of the users on the system, just a user. And you can see a blinking cursor here. It's waiting for you to receive. So this is what we call the share prompt. Share prompt as it is on my board here. Share prompt. Now, okay. So I've told you what the share prompt is. I've told you what the terminal is. What then is a shell? Shell is the program running in the background. The program that is making this command to run. When I typed ls here, ls is, these commands are simply executable files. Take it, that's the way I choose to define it. Commands are executable files. Yeah, on this terminal right now, the commands you have, they are executable files. So they are present somewhere. All right. They have instructions to execute. This thing I did before, if I do it again and enter -l, it will do something similar to what it did before, but in another way. All right, in an entirely different way. Now, all of those instruction it has all of those instruction, and this is a C file actually. a C executable file. Let me illustrate what I mean. Let's write a simple C program. Sorry, I'll be using Nano just in case you're not familiar with it. Just the way you could use Vim or use Emacs. We can as well use Nano. Nano is a text editor, and of course I don't have Vim installed here. I would have loved to use it since it seems to be very popular. You can see it's not installed. I also do not have Emacs installed here. But I have Nano installed, so I'll just use it. You can see version 6.2. All right, let's go. Nano. I want to create a file. Let's call this one hello.c. All right, so this is a C file. First of all, I want to have this header file included, so I'll say include stdio.h, and that's now to do is int main void. Okay, and I just want to give the instruction to print out the string hello world. Okay, not hello world now, hello Topman. All right, that's all I wanted to do, and I wanted to return 0, and that will be all. That makes it. So I'm going to save this and exit the. Oh, do I have GCC installed? Oh my god, I hope I do. Okay, I do. Okay, so next thing I want to do is to compile that file, right? You can see the file is available there, hello.c. So I want to compile it, and what I need to do is call GCC, say I want to compile the file hello.c, and I want the executable to be called, let me call it say hello. Okay, let me just call it hello. It's fine. It compiled that error. You can see the green one there. That green file there is a executable file, right? And that file, to execute it, I have to do /hello, and I run it. It prints hello Topman. Of course, there is no. I didn't add a new line, so it's not adding a new line. Let me go back to that file and add a new line to it so it works. Where nano hello c, come to this line, move to the end, and /n, and save that, exit. Okay, compile again, and now run the executable. So look at that, it prints hello Topman. I was telling you that every command you see here is an executable file. The reason this I need to do // to run this file is because I am inside this same. I'm saying the dot means inside this directory. Find this file. That's what it means. If I was inside another directory, let's say I was inside the directory named documents, right? Look at it. There's a directory named documents. The second by my left on the top. So if I cd into documents, right now inside documents, it's empty, right? If I want to run that same file, I'll do dot means the parent directory, the directory before this one, the directory that is housing this one, and I do hello world. It means I can run this file from from anywhere, from any location. I just need to reference its location very well. I just need to reference its location, and it will run. But there's a place where I will keep it. I don't need to reference the location again. It will be global. It will be available on every location wherever I am. What place is that? That place is called bin. So we have the user /bin, right? And we'll also have bin itself. So you get it from the root directory. So if I do cd /, I'm going to the root directory. Okay, here I am. So if I list what is here, you can see that we have by my left the first folder. Sorry, the first folder as bin. Okay, so if I cd into user, look down by the left, sorry, by my right, down, you will find a file. Look at it here. This directory actually named user. If you have the time, you can just play around. If you move into this user, you will find another bin directory. Okay, let's not talk Let's not dwell too much on that. So inside this bin directory, if I move that file, remember that file, I did it inside in the home directory, and the home directory is represented with tilde, this thing that looks like snake, like rope, right? So if I do ls tilde, is here, you can see it there. So I can move what is there. I can move that thing from tilde slash hello the hello itself, the executable file. I can move, once I move it to this bin, it becomes a command. I can run it like a command. Watch me. Now this is the what's it called now? The source, right? This is a source, right? So let me specify the destination. Like I'm moving hello to slash bin. Okay, since I am, yeah, to slash bin, right? But this will not work until I add a sudo command, because you don't just touch here. I will need permission to do this. Let's try. You can see you cannot move this. But if I bring back this command, come here and do sudo, it should work now. It will ask me for my password because this is my computer, and then I am not signed in as a super user. If this thing was hash, if this prompt here ended with hash, then it would have been there would have been no need for sudo. But since it ends dollar, there's a need for sudo. So I will just enter my password. It's actually entering, but nothing is showing. So enter. Now it has moved. My password was wrong. I'll do that again. Okay, it has moved now. So if I ls tilde, I won't find that file there again. You can see hello.c here, but the executable itself has moved to bin. It has moved to bin. So since it has moved to bin, wherever I am, no matter the location, I don't need to do ./ or reference each location again. I just need to say hello. If I type hello, you see it's doing what I ask it to do. I only ask it to print hello world. That is how this ls is executable. That is how what else pwd is an executable. Let's find them. They are inside bin here. So let's move into bin. Now when you list what is here, there are so plenty. Let me clear this screen. When you list what is inside bin, there are so plenty. Watch. You see among these things you will find my hello. They are alphabetically arranged. So let me look for H. This is G, so H will be up there. All right, let's do this. I'm looking for the L loads. I just added here now. Let's go up. You may have seen some things, right? Where is that hello? Appear. All right, look at hello here. So I added this one. It has joined itself with other files that are here. So many of these things you're seeing here are C files. They're just C executable files. Let's find ls. 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 Come on up here. If you know what the command ls does, look at ls. If you know what it does, look at ls here. Is that not interesting? I must look for ls. It has to appear. ls. Look at ls. So this is an executable file that has instruction that once they do ls, do like this. If they do ls and they add -l, do like this. If they do ls and they add -a, do this. So my own file is here now. You can see it. My file has only one simple instruction. Once they just call you as a command, just print hello Topman. Isn't that interesting? Let's look for pwd. If I leave here, pwd. Should be somewhere here. Look at it. I found it. pwd. So you see, you can find many of the commands that you use. Some of them you find them here. Now some commands are inbuilt and not found here. Commands like okay, let's check what we can find. Echo. Okay, here is echo. Now let's look for cd. Okay, so you can go on and on. Where is cd here? So you can see there is no cd here. Why is there no cd here? You may have used this stuff before. Change owner, change group, change um, change mode. I'm sure that most persons have used this before to make a file executable. Alright? Once a file is executable, you move it to this place. Even scripts will run. Once you make it here, execute just executable files, scripts, binaries, whatever. So long as they are executable and you put them here, they become the command. The question now is, why is seed not here? That's the first question I'm asking you. I'm not going to answer that. So you answer it and get back to me. I mean, see you in the next section. I hope to remember to talk about it. Okay, that's by the way. Now let's leave this place. Now, when you come here, be careful, because if you delete, you need to be very careful. I will only delete my own. So let me delete the one I put here. Am I not in this place? Okay, hello. I have deleted it. So if I do hello again, the system does not recognize it again. So I'm going to clear the screen and I'm going to navigate back to my home page, and here I am. All right, I did that to show you that a program, that's how shell work. It is shell that is making this program work. Now if we go, let's go back to that place. Let me show you. We are using a type of shell called bash. All right, so let's find out what that bash is here. Up to BA, that's it there, bash. So this is a shell, this is a shell that is running. So writing your own simple shell is writing your own program like this, that can call ls when they type ls, that can call these commands, you know. So this bash is the one calling this command. When I do ls, this bash is calling ls, you know. So a shell is a program that that provides an environment, right? It's a program that executes other program, right? It responds to commands in the form of text. When you put commands in the form of text, it responds to it and executes that command, that the program that test is calling, is invoking, the executable file that test is invoking. Okay, now this is C programming, and you ask to write your own simple shell. Just know that you're being asked to write something that is able to call programs from this place and let them execute when you type command inside them. We'll understand it better as we make progress. Now, what next is on my list? Commands, simply executable file. Okay, I just did that, right? Yeah, commands are simply executable file. Now, everything happening on this system has a process ID, right? Even the bash that is running now has a process ID. That is the command to know the process ID of the bash, of the bash, yeah, of the instance of bash that is running here. Now, mind you, there are different kind of shells. I don't want to start talking about those right now, but have it in mind that there are several of them. Let me duplicate this and just type out several of them. My mouse is acting, making me slow. So there is CSH, C shell, there is TCSH, there is can I know them now? There is this first one that history will always talk about. So Thomson shell, right? Built by again Thomson, if I'm not mistaken. So Thomson shell. There is a Bourne shell, and there's this one we are using. Bash is born again shell. So it is spelled like this: born again shell. So that's what bash is, and that's the one I'm using here right now. You know, that's the one I've seen most people use. There's even ZSH, just to tell you there are several of them, and now you're going to be writing your own. Of course, like it sounds, simple shell. That means you're not expected to implement everything there is in everything that makes up a shell. You may want to read up the histories, you know, read about shell. I mean, if I start talking about everything here, these sections will be longer, much longer. And another assignment I want to give you is read about system calls. What is the difference between system calls and normal function? What are system calls? Just try to read about them, and hopefully we discuss them together in other sections. All right. PID, PPID. Now, remember that the C program I wrote, I instructed it to return 0, right? Let's check. If I cut into that program, hello, let's see. You see that it has an instruction to return 0. Let me even make the line number display. So on line 5, sorry, on line 6, there's an instruction for it to return 0. So if I want to check now, say the last process that ran, what was its return value? I'll do dollar question mark. So it tells me that 0 was the return value of the last. Okay, let me not deviate. Right now. So echo dollar dollar. You're talking about PID or PPID, right? What does PID even mean? PID means process identifier. Process identifier. Let me put that on my board. Do I need to? You can. Process identifier. That means process identifier. Alright. So when you see PPID, what added to the word is the word parent. Parent process identifier. And parent is literally parent. That means the process that gave birth to another process. Yeah, if a process gives birth to another process, it becomes a parent. Now this is how you know the PID of the current instance of shell that is running here, right? Look at it. The PID is 5124. 5124. That's interesting, right? That's interesting. Now, when we say instance of bash running, it's important you know that. Okay, let me explain what I mean by instance. Instance, just assuming you have two phones. Let me put up some diagrams here. I hope the example I'm giving now is global enough for everyone watching to be able to relate with. Assuming this is my phone and this is your phone, and I want some, let's say a video from your phone, or let's say a photo from your phone, and you could choose to send it to me via Zender, right? You send it to me via Zender. Now, does it occur to you that you're transferring a file to me? Why doesn't the file leave your phone entirely and come to my phone? You see, you end up duplicating the file. I end up having a copy, an exact copy of the file you have, and you still have the file. It didn't get missing. It didn't get lost. But you transferred. I mean, if you transferred, why did it leave? So take that as take the file to mean a process where these two are not the same thing. They are similar, they are built from the same, they came from the same item, but they are not the same thing. You have your own now, I have my own. How else do I explain it? How else do I explain it? No example is coming to my head right now, and I'm on the speed then actually. But that's what it means actually. So bash is there, bash is running. Let me do this. This is with the same file I wrote. We are going to get process. We are going to write a. We are going to run off. We are going to add something to that function I wrote earlier. That program I wrote earlier that prints hello Topman, and we're going to get the process ID. We're going to have it print the process ID, right? And let me just show you. Watch this. The process ID does not change because what is here, what is still running is the same instance of bash. I can call another instance of bash. If I type bash here, it looks like nothing happened. But if I do echo dollar dollar again, you will discover that something happened. Echo dollar dollar. You can see the PID has changed to 5817. Look at that. It has changed. If I do bash again, let's do again. Echo dollar dollar. Should add 5959. Let me show you what happened here. What happened there was that there was a bash process running. All right. Let me present that with this diagram. Uh, Still like this. My mouse is acting up. I'll just not mind it. It's trying to distract me. So what happened now? I then called another instance of bash. So that bash that I called now, the second one that I called, is running inside this first one. I hope I want it to be inside just to illustrate. God help me. Yeah, I don't want to accept any distractions. I'll just go ahead with a slow mouse. All right. So here it is. It is the bash, the second one that I called, right? The second one with the PID of 5817 is running inside this one. Then I called another one again, the one with PID of 5959, if I am not mistaken. I call it. It is now running inside this one. It's important you understand how these things behave and all of this. So you can't just get up and start writing your own a simple shell without understanding things like this, right? So this is PID, process identifier, that I'm explaining. Okay, now let me prove that to you. I'm going to exit from this one. You can see the PID is not changing. If I type exit, watch this. The PID has become 5817, which is what it used to be before I got into this one. So what happened is that I have now exited from this particular instance of bash. I am now in this one that has a PID of 5817. Let's go back to this one that has a PID of 5124. Let's see. So I type in exit again. Let's check for the process ID. This is that 5124. That's what it used to be. Let me scroll up just to get you, to make you sure. You can see it there, 5124. 5124, right? So 5124. We are now in 5124. So 5124 is supposed to be the last one. There is no other one on which it is running now. It is the parent. It's the one that is running, the main one that is running. So I've removed these two. I've exited from these two. If I exit again, I am leaving the terminal. The terminal will close. Let's prove that. Let me prove that to you. So exit, terminal is closed. It's no more open. It's no more open. You see, that's quite interesting, right? So I'm going to open it again. I'll just hold on Control Alt T and get a fresh terminal. That's a fresh terminal. I'm going to feed the screen again. Oh, I will need to zoom in again so it becomes bigger, larger as it used to be. All right. Okay. Now let's do something. Let's try to get the process ID. Let me show you something. Let me demonstrate process ID with this file that I wrote. But how do I get the process ID? I want to be able to print the process ID, the process identifier of the instance that is running. Okay. There is a function called getPID. So you're going to consult the Linux manual. Of course, I'm on a Linux system. This is Ubuntu 22.04. So let's see. I hope this command is the correct one. So man getPID. Let's go. Is that it? Is that it? Yes, it is. First of all, it tells us the header files to include. Right? If we want to do man PID, we need to include these header files. Then it tells us that there's such a thing as getPID and there's such a thing as getPPID. Of course, getPPID is obvious. It means parents, the parent process identifier. Okay, and before you use getPID, it means you have to have a program where a process created another process, where a process was created from another process. I just demonstrated creating process from a process. I created a bash instance of bash on bash and created another one and exited. So you need to write such a program on C. Now that's not something you might understand until we do some demo or practicals, but to an extent you're understanding it, I believe. All right. So it says include this, and then it describes that this guy returns the process ID of the calling process. This is often used by routines that generate this and all of those stuff. And so when they say it returns, it means if you want to know what something returns, you have to save it inside a variable. What do I mean by it? Let's work with return value a bit. I hope I'm not taking too much time going around these basics. Let's find out the return value of this printf statement in this program that I wrote. You will see that each return value is different. Return value and output are not the same thing. It is outputting hello Topman, but the return value is different. How do we know the return value? Let me do this. I think I want to create a new tab. Yes, and let's read about printf a bit. Printf. So you see that printf. Let's go straight to the. Is this the one for C? I don't think this is the one for C. Here I'm going to skip. I think let's try man3 printf. Okay, here it is. Now it tells us that I'm going to scroll straight to the return value. Okay. This is where. Is this all? Okay. I wanted to scroll to where is describes each return value, but to save time, I don't know what is happening here. To save time, you are seeing that it has int first, and when you're declaring a function, the first data in C, you state the return type, right? The data type of the return value. So it means that printf returns integer. Having known that printf returns integer, what then comes to your mind? What then comes to your mind? You need to save. The way we get the return value is to save it inside a file. So I need to have an integer file. Let me call this one arrow value. Arrow val for arrow value. Right? I just declared a variable here, and I want to save inside that variable whatever the return value of printf is. Okay. So after saving it, I want to print that particular value. Right? So I will say print f. The format specifier for integer, because I know it's an integer, and then I want a new line, close this, and then I want it to print that from rval, and that would do. So let me save this, and no point exiting. I have to, if you observe, I have two tabs right now opened. What I did was Control Shift T to open it. Now I'm swapping between them by doing Control page down, Control page up, right? Okay, so I will exit this manual. I think I need to increase this one as well. I need to zoom in a bit. All right, now the file is here right now. Hello.c. Let's compile. Hello.c, give me the output as hello. All right, here we go. If you watch, we have a green colored hello, a green colored file showing that it's executable, right? So let's execute it right now. Now it prints hello Topman and prints 13, because each return value, the return value of printf, it counts the number of characters it printed. Now hello has 5 characters, right? Topman has 6 characters. That would mean 11 characters, but there's a space here. This space is 1 character, that means 12. And there's a new line here. The new line is a 13th character. That was why it gave us 13. All right, I did that to show you that if you want to cache the return value of I'm going to take all of this off. Let me just comment them off. Now I did that to show us how to cache the return value of any function of a function, okay, in C, right? And now let us take us back to this place. How that the return value of get PID was stated, right? It was stated, right? It returns the process ID. So how do we cache return value? We have seen that return value is not int. The return value is of type PID, right? So the first thing we want to go and do is to include these libraries that are here. First one is sys types, right? So let me go. I'll go up here. Where's my cursor now? Come on, I can't find you. All right, you can see it right now. So I'll do this. include sys types dot h, and then the next one is uni std. All right, so include uni std dot h. All right, if there's no bug in this code, everything works well. So after including it, there's a kind of data type that is not integer, it's not char, it's PID underscore T. This is a data type, and this is the data type that it returns. So it means we have to declare a data type of a variable of this data type to be able to hold the return value, right? So let's go. If I declare this variable PID underscore T, and let's say, let me call it arrow. Let me call it arrow value this time. Arrow value, so it will be different from the one I declared earlier. Now, we want to use it to catch the return value of the function. Now, next thing we want to do is to call the function. What argument does it take? You can see that obviously this is a prototype. It says void. Let me see, it does not take any argument. It means that when you call it, you just type the function and you say like this, and it will return what it needs to return. So here I can save the return value inside the variable arrow value, because our value is of type PID underscore T, and the return value of get PID is of that same data type. I hope this thing is flowing, right? So we want to catch the PID of this process, right? After catching it, what next would I like to do? Of course, I would like to print it out. I like to print it out. So let me write a print statement. My work getting so rough. Let me write a printf statement here for it. So printf. Now this is not an integer, so what's the best okay, all right, let's just do this. Printf %i, and so let's say, let me make it a statement. Process, let's say PID equals %i, and what I want to print is whatever the content of arrow value is, which of course will be returned from get PID. I hope this is making sense. Give me some feedback if it's making sense. Come on, just type a comment. Tell me your understanding. By the way, this whiteboard, you will find the what now? The link to the whiteboard in the video description. You can come and watch the things, and if you need to. And I'm going to have this code pushed to repository, pushed to Git. That's why I don't want to delete any code. I'm just commenting them, so you can have access to them and play with them. Yeah, you'll find a link in the description of this video if you're watching on YouTube. Yeah. Okay. That's it, right? That's it. Let's go and try and see whether this works. I'm saying PID equals this. All right. Let's save this. I don't want to close it, so let's go to this other part of the terminal. What I'm simply doing is I'm using two terminals. I just open them as tabs, right? And I'm using them. I'm switching between them. I'm using one to type. I'm using one to run the program. It's no magic. It's no magic. Like if I right click here, if I click on this plus, I can create new tab. But I like using shortcuts a lot, so let me click on it. You can see there are 3 tabs now, but I don't want this one, so I'm going to close this one. So I have 2 tabs open, right? So there's no big deal. Okay, our program is here. I want to compile it again so that it will, the executable will carry the changes that I have. Now, I did not add semicolon after after calling this function, so I need to end the statement there. So let's go. All right, so let's compile again and see. More problem. Undeclared first use. I thought I committed off the code. Arva. Okay. I understand. I'm supposed to take this off. arrow file is not being used here right now, so let me take this off. Okay, let's clear the screen a bit. It's getting rowdy, and let's try to compile again. Now it compiled that error. Our file is there, green colored, executable. So let's go. Are you seeing that? Hello Topman, says the PID is 7137. I want you to notice something. If I run this file again, it's telling you that the first one that ran, the first instance, is not the same instance. They are different. They are very different because it's a very short program that runs in less than 1 second. So its lifespan ends in less than 1 second. So the process does not continue. That's why you will never get, you might never get two with the same PID. You can see different process ID. So that's it about PID. As for PPID, I would have loved to demonstrate it, but it will make me do something complex that might confuse you if you're a newbie or if you're learning from scratch. But as we make progress, maybe when we get to creating process, creating process, we'll talk about PPID, because this is where you now create process. You now make a process to give birth to another process, just the way I did with Bash, but this time we'll be doing it with C program. We'll make a process, give birth to another process, and give birth to another process. There might be entirely two different processes. There might be the same processes, similar processes, identical processes, right? So when we get there, I'll talk about PPID. Hopefully, I will get there. Arguments. What are arguments? Now we looked at the manual earlier, some minutes earlier, and we saw that some of the functions we tried to look at, it was printf, right? Printf takes argument. We saw that getPID takes no argument, right? So when the function is being defined, you see those parameters being given to it. I could make this function take argument. Let's modify the function to take an argument. It's an argument. So it's not even a function. Okay, let's turn this code to a function. So I will say, let me write a function up here. Okay, let me write it down here. I'll call it it should return nothing, so void, and I don't want it to return anything actually, and it should let me call it say hello. It should take a string as an argument, so it should take the name of the person, right? And all I want it to do is to say hello to that person, so you should just print f hello %s, with an apostrophe, and then print a new line. And of course I need to state that %s will be whatever was passed to it as the argument name. And since I'm not returning anything, so I won't write any return. I don't need to write any return value, and this is it. And to make this thing work in my code, I need to come up here and declare the prototype. I'm sure this is not strange to you by now, so I will say I have a function down there, and the name is say hello, returns nothing, and it takes one argument, which is an array of characters. Okay, all right, and then I need to end this with semicolon because this is the end of the statement, and that way I can now call my function here. I want to turn these other things here to this other line to the comments. If this was Vim, it would have been fast. I don't know nano shortcuts, like I'm not used to nano, but I wanted to cut this in off and bring it out, get it out so that it doesn't get crowded, but it's fine. I don't even know how to display line numbers here. Okay, but we're making progress, right? And so now that we have a function that does that, let's now call this function. Let's call the function here. So the way we call the function is to say hello, and this time we'll give it an argument. So say hello to who's in this section with me. Okay, let me put my Harrison. Alright, so say hello to Harrison. Let's see what happens. Let's see what happens. This is us calling our function and giving it an argument. So if there's no bug in this code, if everything is correct, it should be able to print hello Harrison and print the process ID of the program that ran. So let me save it, move to this other terminal, compile it again. No error. I will clear the screen and I will run the program. It says hello Harrison. You can see that. So that's argument, and I have reasons to believe that most of us watching now, or most of us with me live, know this thing. So I'm just reminding you watching. I'm just trying to move you from the known to the unknown, right? Command line argument. These are things you've done before that you may not have paid attention to. Probably if the first time you're hearing about it, no problem. And that's why I'm here. I'm here for you, right? Command line argument. It appears I've got to the end of this section already. That's interesting, right? Okay. Please, if you have a question, post it as a comment and I will sure answer you. And if you're here, you're not subscribed to this channel, come on, what are you waiting for? Just click on subscribe, okay? Click on subscribe and follow me, right? You can follow me on GitHub. If you like Facebook, follow me on Twitter. I'm there. On LinkedIn, connect with me, right? Let's keep learning from one another. Thank you. And if you're not on Code Tribe Discord server, please do well to join. You will find the link in the description. If you're watching from YouTube right now, you find the link on the description. Okay. Command line arguments. It's just about, remember how you used to write bash scripts and you do something like rather than having pwd that prints the ID. I think I want to make a new directory for this session, so let me call it simple shell series. I will turn it to repository because that's where I'm going to push the code to. So I want to move this hello into that place. Move anything hello into this directory. Let me confirm I'm already here. So I'm going to move now into the directory, and here we go. Clear the screen for me. So if I do pwd, this is what it does. Record that I can write a script. Let me call this one what will I call this one? What will I call it? Working directory. Let me call it current dar, right? This is a script I'm trying to write, a bash script for the matter, and I think it's not something strange to, it might not be strange to you. So how that we add this stuff here, being what we call the shebang command, shebang, right? Shebang. So being bash. Okay, what does it do? Well, what does it do? I don't want to deviate. But what will happen if I don't put the shebang command? I just say pwd. What will happen? Let's try and see. So I've closed it. Let me, I think I need to close this file. No, let me close the other one, the C file. This is saved, right? Close it for now. I'll come back to you. And let me also move to the directory here on this other terminal. Clear the screen a bit. Of course, we have to make it executable, right? So how to do that is chain mode, chmod. There you go. User, you add user plus x user. You're adding to the user the permission to execute, and you're doing that for the file named current there. And so when you do that, we are now call bash. Okay, even without making it executable. All right, let's do this. Let me change the permission. Minus x. All right, so it's still white colored, not executable. What will happen if I try to run this file? current there. It's not executing. It's saying permission denied. Permission denied. So could it be because I did not add the shebang command here? Could that be? Now watch this. If I call bash and give it to it, I say bash, hello bash, do something to this file. You can see it's executing. It's doing exactly what PWD does. It's executing right now. It's executing right now. Meanwhile, if I make it, if I made it executable, then I would have run it like a script. All right, let's go. It's green colored right now. / current there. Now it's executing without me calling bash. It's executing, and that's stuff that's shebang command that I used to put is no more there. It's not there and it's working. Why? Well, that's not what I've come to answer today. But let's just put it there. So I don't do too much. I don't do something that looks magical. Yeah. So PWD. Let's not say echo. You know what echo does, right? So if I say echo hello Topman, it will do what the C file was doing earlier, right? What the C file was doing earlier, it will do it now. Okay, so let me save this and move to this other terminal. This time I want to run the file again. Now it says hello Topman, right? Hello Topman. But we can actually command this file to recognize command line arguments. What are arguments now in the command line? Command line arguments are those things we put after the main command, whether it's -hello or a word, let's say revert. You know, those are command line. This script does not have any instruction to do anything to any argument, any command line argument. That's why nothing is happening. Right? Nothing is happening. What if I went to the script and say, hello, I don't want to hard code the name that you will greet, but greet any name that was given to you as the first argument. $1 stands for the first argument. Greet any name that was passed to you as the first argument. Let me save this. Come back here. And now if I run the program again, right, it's saying hello because there was no argument pass. Hello. If I now say type Topman here, it says hello Topman. If I type Harrison here, it says hello Harrison. If I type Big Head here, it says hello Big Head. Now if I type hello Topman and add my surname, you see it takes only Topman because it has instruction to print only what is in the first argument. If I change this 1 to 2 right now and save it and run that same thing, it will leave Topman and print my surname Paul-Dike, right? If I go here and say, okay, I want you to print the both of them, $1 and $2, and save this and come here and run this again, it prints both of them right now. Okay, I hope I'm not deviating, but this is command line argument. This is me passing argument to my script, and my script is able to do something to it based on what I've asked it, based on the instruction I've given it. We can do such a thing with C program as well. Did I just say that? I just say that? Yes, I just say that. Now we've learned about, don't forget, we've learned about a system call. Is it a system call or a function? Well, ask you to learn about system call, so you find out. Get PID. You can put in the comment. Let me see. Is get PID a system call or a function? We've learned about get PID, and now we're going to learn about something called argv. So argc, let's call this int argc, comma int argv. Sorry, car. and V. Okay. Okay, so that's the thing to learn about. What interesting, right? Okay. Yeah, put in the comments. Let me see. You think getPID is a system call or just a function? Put in your comments. Put in your comments. I'll reply you. Okay. Um, so let's now do that thing we did with shell script. Of course, bash script means shell script because bash is a type of shell, right? It's a program that uh, executes other programs in response to test command. I got this definition from um, Wikipedia, right? Wikipedia. Yeah, while I was reading, trying to read about the history, the first shell I was written, first Unix shell, and things like that. Okay, and then Ken Thompson and likes of them. Okay, we are making progress. Let's go back to our terminal. This time I'm going to close this file. I'll close it. Copy saved. Close. And I will go here and open the file that we had opened here before. Nano hello. Let's see. Okay. Before I do this, let me show you something interesting. Just to show you that the files, most of the files, that are running there in my system, I have customized commands actually. If you check my YouTube playlist, you will see a playlist where I taught, where I taught how I wrote my videos like that, and look at them. This is the part 1, this is the part 2, this is the part 3. Creating custom commands. I have custom commands. If I want to clone a repository, right, I don't do the Topman way, right? I don't do that's to demonstrate that. That's to illustrate that a lot of things are just you see that these commands are executable files. For example, watch here. There is no repository. There's no repository here, right? But I can clone my repository by simply doing gpat. Then I can say me, right? So that is my own. Then I go LAX, I is spelled, I think low level programming. Okay. That's it. So I say dash me and I give it the name of the repository. Let's see what happens. Oh, it didn't do that. Oh. Okay, what happens when I give you only the repository? Let's see. I think I'm not getting the command. What am I not doing right? Dun, dun. You have to work. So clone. Okay, I think I'm not spelling it right. GPAT LX low level programming. Let me check for the let me check for the log. It's just by the way, right? Logs. Okay. Dot logs. I program it to put the error somewhere. So GitHub Paul-Dike LX low level and .git not found. Okay, I didn't spell it well. The programming should have to. Okay. So let me clear the screen and go and do it again. So this is me. It's doing what I ask it to do. So programming, I think there's a stop. Yeah, that's the problem. Let's go now. So let's see. So it has cloned it. You can see. Just to show you that commands are just executable files. Now this one that is executing, I wrote it with bash, not even with C. Right? And it's working like this. I mean, you can do more. That I want to show now. You can do more. If I start talking about it, I may. You can see those videos, right? If you're interested, I may take longer than I want to. into this section, so I'm deleting that off. And let me show you one more thing that's interesting. If I cut into hello, this is not hello.c, this is hello, the executable file. Look at plenty of rubbish that is inside. Rubbish to us, right? This is the one that has this is the one that has been translated, compiled into the computer language. Now, if let me clear my screen and let me move into a bin to show you something, right? All right. Now here we have, certainly you remember that we have ls here, right? Let's cut into ls and see what ls look like. And so ls, clear. You can see this is ls. So it's you trying to write a file that when they compile it and bring out an executable. I mean, I'm describing your journey to writing a simple shell. That is the end goal. You want to write a file. You want to write files, source codes that when they compile them together and produce an executable, that executable will work in like bash. To emulate bash to an extent, but not completely at all. That's why it's called simple shell. It's simple. All right, I'm going to clear this place, the screen, and I'm going to go back to where I was. I've looked for trouble. Okay. All right, you're making progress. I'm going to what's the shortcut for closing tabs again? Okay, I'll just do this. All right, and here we go. Okay, we're making progress now. I was trying to use this file to do what our bash script, this bash script here named current directive was doing. So let's see how to make it do that. Is to change this. I think I don't want to use this again. I want to, let me do it this way. Let me take everything here down and use the multi-line comments on these lines of code. So I will come here and I will add the comment this way, and I will take this off here, take this off from here, and begin the comment from here. Alright, so they are all comments now. Alright, so let me add new lines of code. I'm not using the function down there. I'm doing something entirely new. So ignore the function that is down, ignore the prototype that is up. I'm not using them. I just don't want to delete them, so that when I push them to Git, they will still be there for you to play with if you're interested. Okay, now I want to change this to what I wrote on the whiteboard earlier, where this is int argc, comma, car argv. I will explain this later. I think I will end this section by explaining what this prototype is doing here, what it really means. Okay, and we're talking about command line arguments, right? So now I want to give it an instruction. I'll say print f hello %s, put a new line. But where should %s come from? We're going to ask it to go and get whatever was argv1. Remember, in bash we are doing $1. Now I'm doing argv1. Let's see whether this works. If it doesn't work, come on and fix it. All right. Oh no. Okay, saved. I just saved and exited. I didn't want to exit. Stay there for me. Okay, okay. Go to this other terminal. Let's run our file and see what happens. What's that file again? Current hello this time, right? So let's compile again. We'll do the compiles so that we'll see we'll have the changes here. All right, let's see. I've changed the order actually, but it still works like this, right? So it has compiled, no error. So let's go hello. See what happens if I don't pass argument to it. It's a hello null because it has checked the first argument, right? The first argument, not the first argument per se. It has checked the position of argv1. There was nothing there. It was null. That's why I printed null. It's not like bash that will handle it and not print null. Okay, so if I do it again and say hello Topman, look at C doing what we are doing earlier, right? If I say hello Topman Paul-Dike, it takes only Topman. If I go back to the file and say, hey, okay, I want you to print what we've got at argv2. If I save this, go back to my terminal, compile that. That's the thing we'll see. You have to compile again, compile it again, and run it. It prints Paul-Dike, hello Paul-Dike, and ignores Topman. If I go back to the file and say, okay, print %s %s, and the first %s should be what we have at argv1, and the next one should be what we have at argv2. Let's save this and go back and compile again. Since it's a C file, we'll have to compile again after making changes. Now it's printing the both. If I add more names, it won't even bother, right? If I go and add those things, those random values at the beginning here, let's say put it here, testing. It has instructions to get the first two, so it will get the first two and ignore the other ones. So this is it about command line arguments. But now let me explain. In that particular prototype, the main in C has 3 prototypes. We'll talk about that when we get to this. I think it's the last thing here, right? Yeah, main in C. But right now we're working with the second prototype, right? It has 3 kinds of prototype: the int main void, and this one, and then. So what is really this thing? Let me not assume that you know, right? But what this really is this: if I had written this thing like this and say car, and then put square bracket here, it will work. You want to know whether it will work? Try it on your own. It will work. Remember that this is a string. String is an array of characters. Alright? In a way, the way I used it before, I used it like a double pointer. Remember? Right? Okay. Like a double character pointer. Let me explain. argc counts how many arguments was passed. argv is an array of strings. An array of strings. It means that when I did the first, when I added those 2 names there, it created an array named argv. Yeah, an array named argv, and inside that array were the following values. So the array was like this, where at index 0, like this, at index 0, it had the name of the program, and of course the name of the program, the program executing, actually it was executing like this, so it had that at index 0, right? Comma, it then had, what am I doing? How best do I represent this? Okay, let's do it like this, or like this. All right, So it had this, and then it had the first argument that passed to it, which was Topman, comma, and then it had um, Paul-Dike. All right. Okay, so that's it. So the hello, the name of the whatever program was executing became argv0. Whatever program was whatever program was uh, whatever argument that was passed to it first became argv1, and I think this would be like this. Uh-huh. Uh-huh. So it became argv1, and the next one became argv2, and it will keep counting wherever it sees space to break and take what it counted as a whole, as one whole thing, right? So this is a whole string, it's another whole string, so on. Meanwhile, what argc does is to count. So argc will count that there are three things here. Argc will count that there are three things here. So if you wanted to print, okay, let's say, let's add another print statement and say print f. Let's see, you passed percentage I arguments, right? And of course a new line, and percentage I wanted to get it from argc. Okay. What I have up here is a comment, right? So it's not doing anything. The only instruction I added was just one line that I added right now. So I'm going to save this and let's compile that file again. So it compiled with that error. Let's clear the screen and let's run it again with this one. So it says you passed 3 arguments. Now I passed 2 arguments, but it is counting 3. Why? Because it's counting everything on the array. Everything on this area I showed you is counting 0, because the element at 0, element 1 will be at index 0, right? So it's counting 3. So if you want to be accurate, you do argc minus 1. Then it will accurately count how many arguments you passed. It will accurately count how many arguments you passed. Let's save this and run it again. We have to compile again and run it again. It says you pass 2 arguments, right? 2 arguments. Now watch this. Why the first instruction has the first printf has instruction to print only the first 2 things passed to the argument. The other one has instruction to count every single thing except every single thing that was passed and to subtract 1 from it, right? So if I pass more arguments here, let me add all these other guys. Harrison, I've used you so much now. So Godwin, Ebube, Joel. Now how many do I have here? I have, this is 0, right? Okay, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So argv contains 6 things, and this guy will count 6, and we've asked it to subtract 1. So it should tell me that I have passed 5 arguments, right? Which will mean 1, 2, 3, 4, 5. Let's see. So that you passed 5 arguments. So it is programmed to count how many strings are in the array. It's an array of strings. It's programmed to count it. Now, just for your knowledge, this thing is just some convention. If I change this to int goat car fowl, let's find out whether it will work. And that will mean that I will need to change this to goat, right? Goat minus 1, and I want to change this to fowl. So let's see. let's see, let's print only the last one. I want to do something. Let's see, print ag fowl good minus 1. Is that it? Let's see what something is going on in my head as okay. How do I undo? I'm deleting some things now. I don't want to delete any line of code, but no problem. I've deleted it already. So the last argument passed was %s. Alright, so %s will be whatever argc was. Argc is now good minus 1. It will not go. So if the argc counted 4, it now go 4 minus 1. 4 minus 1 will be 3. It will now go and print argv of 3. That means the fowl of 3. Okay, so this line is supposed to fetch us whatever the last argument we pass to it was, and this guy is supposed to tell us to count the argument we pass. Everything that is in the array, not including the program passed. Let's see whether this thing is working the way it's working inside my mind. Okay, I'm freestyling. So we need to compile again. Oh, it compiled that error. That's exciting. Now let's roll. It should tell me that I printed 5 arguments, and it should tell me that the last was Joe. Let's see. See that the last argument passed was Joel. All right, let's add some to it. Let's add Joseph. Let's add Linda. Let's add Drake. So we have let's count that. We have 1. We're not counting this, right? 0. We have 1, 2, 3, 4, 5, 6, 7, 8. So she tell me that I passed 8 arguments, and I should print Drake. Let's go. The last argument passed was Drake. You passed 8 arguments. I'm using goat and fowl when it is working. So just know that it's some convention. It's some convention. So let me change that before I close the file. Okay. So nano hello.c. What is happening here? File edited by Topman. Open anyway. Nano, don't play with me. What has happened? What just happened? That's it. I thought I had lost the file. Okay, so let me change this back to int argc. Some people can do it. Some people can write ac, and here write av. It's the same thing. Some people can take off the box and put 2 asterisk here. It's the same thing. It's just the same thing. So here will be av. And here will be AC minus 1, and here will be AC minus 1. Okay, let's just confirm that our program is working well. Please feel free to post questions. I want to see plenty of questions or some feedback. Come on, how is it going? Is it flowing? Are you understanding? Let's get it. But invite others to come and learn, right? Let's learn together. Let's learn together, and I'd like to hear from you as well. Feel free to inform me and teach me what you know. Yeah, feel free. I like my class being interactive, even if I've been the only one talking since. Although I'm trying to beat time. Let me go and check that my program is working. I will compile. No issues. So let's do this. So the last argument passed was Joel. You passed 5 arguments. Alright, so that is it about command line argument. I've exhausted my objectives for section 1. See you in section 2. In section 2 we are going to take it from Okay, should I go further? I feel like going further. Talk about get line and string talking. String tokenize. Okay, we'll continue from get line, string tokenize. It still has to do with command line arguments. We'll continue from there in the next section, and then we'll learn about executing a program. Yeah, I think we should learn about creating and suspending processes first before learning about executing the program. And the moment we learn about creating and suspending processes, we have to talk about PPID, parents process identifier. Thank you very much for being part of this section. I am really glad you watched. Please share with others and don't just like it in your mind. Show some support. Let me be encouraged by your reactions. Click on like, alright? Click on like and share the video. Subscribe to this channel if you are not yet subscribed. Let's keep learning together. Thank you very much and see you in the next one.